Alrighty, I'm gonna go ahead and get started. Like I said previously, this will be also recorded and posted on our website for you guys for reference going forward. We are going to be highlighting specific Algebra 1 content today and just kind of how the NumWorks calculator breaks down those barriers that sometimes we see inside of technology. So first, introducing myself, my name is Kylie Sullivan. I am a math teacher in residence here at NumWorks. I was a math teacher for 6 years and just transitioned to this role this summer. And I'm also joined with one of my former colleagues.
Hi, I'm Rebecca. I teach in New York, in the Albany area, and I specifically teach algebra. So I'm excited to show some of the cool features that I use with my classes.
So just getting started, I just want to talk about accessibility with the calculator. So the NumWorks calculator is available online. So we have a free emulator that is accessible for any student at any time. That emulator will be available for students, teachers, anyone who wants to use the calculator. There's no download, there's no purchase, there's no caveat to that. It's not a light version. It's exactly like the handheld. So I encourage you today, if you want to do the questions along with us, you can go to numworks.com and just click on emulator. I will be using the emulator for our presentation. We also have the apps for the Apple Store and the Google Store, which you can download right on your phone. Those are also completely free. So if it's easier to follow along on your mobile device, that's an option as well. Just going over a little bit about the design of NumWorks, we split up our calculator into 3 different portions. So we have our navigation zone, our advanced functions, which you'll see that those buttons are actually in yellow as well for some of your more advanced math functions, and then your basic functions, which will be on the bottom. The navigation zone is how you're going to navigate from one app to the next. We kind of call it our Game Boy zone. So think this is how you're going to go back to the previous menu, select OK, home button, power, and then right, left, up, and down. There's 3 buttons that are really important when you're going through the calculator. The first that I like to point out is we only have one negative button for negative as well as subtraction. So that's going to be the same button for both. Also, our division button, that is going to be how you're going to set up a fraction. It's a toggle that will toggle between answer divided by a fraction template and a mixed number. And then lastly, our toolbox. This is where you're going to click when you want to get to any more advanced math that you might not see right on your screen. Any app that you're in, when you click the toolbox, is going to give you more information, more suggestions of things that you can explore. Our calculator is app-based, so students are going to be going to the apps that are specific for what they're trying to do. A lot of times in reviews and lessons, you can kind of tailor a question for them to problem solve exactly what they need to do for their solution by prompting them which app to go to. So we're going to be just focusing on a few of the apps that are really specific to Algebra 1, and we broke down some questions that will go along with things in those apps. So the first app we are going to be looking at is our calculation app. So there are 4 main topics that I'm going to kind of cover as we're in the calculation app. The first one is simplifying our radical expressions. So I just have a question to kind of show us how the calculator will simplify our radicals. If you are following along, feel free to jump into the calculation app. I'll be showing right on the calculator to my right. So simplifying expressions. This expression has a radical in the denominator. When you go to calculation and you type in this expression, the first thing you'll need to do is set up a fraction template. So to do that, you can click on the division symbol. That's going to create a template where you can then type in the question. So I'm going to do 10 divided by your square root button is right under your comma and above your parentheses. So I would do square root of 2. And the calculator is going to rationalize that denominator. So you have 5 square root of 2, and your answer would be number 3 for that question. Moving on to evaluating functions. So how is a student going to kind of understand function notation and use the calculator to evaluate functions? Evaluating a function, we are going to actually be able to store g of x and then type g of -2 as a function notation question. Under the calculator, this var button is going to allow us to store any function, any variable. So when you click on var, we're going to define a new variable. And what you're going to do is you're going to type the expression first. So the expression is, I'm going to again use my division button to set up that fraction. So I'm going to click division. I will hit 2. Your exponent button is right here below the clear. And then this will be x plus 3. I'm going to go to my denominator. Again, x squared. For a squared, we have its own button. You can also use the exponent if you wanted to. And then -2. And I'm going to store this as g of x. So to get g, you're going to use your alpha button. It will notate up here in the right corner that alpha is turned on. If you were typing more letters and you wanted it to stay on, you could do alpha lock and then hit it again to turn it off. So I just need it for g. So I'm going to do g of x. So now my calculator understands that this expression is stored as g of x. And I'm just going to hit OK to tell the calculator that that is what it's stored as. Now I can actually just type in g of -2, and it's going to evaluate that function for me. So I can go alpha g of -2. Okay. And it shows me that my answer for that question is 1. So it's really great for storing variables. You can store multiple functions and do composition of functions as well. So you can store f of x and g of x, do f of g of 2, things like that. It's really great for. I'm going to do calculating area. So what's great about the NumWorks calculator is we are actually able to input units into our questions. So for this one, we're going to be doing calculating the cost for topsoil for a garden that is 6.5 feet by 36 inches. The price for soil per square foot is $2.25. And then we're actually going to have the calculator round for us. So I added round to the nearest cent as well. So the first thing I need to do is I need to access feet. If I know the abbreviation for feet, which is FT, I can use my alpha and just type that in. For a student, if they're not sure what that abbreviation might be, that's where the toolbox is going to come in handy. So you can go to the toolbox and kind of dive in and see what's in there through this question. So I'm going to type in 6.5 to start. I'm going to use my toolbox for this just so you can kind of see where some of those other features are. So I'm going to click on my toolbox. I'm going to go down to units and constants, and then go down to length because feet is a measure of length. And feet are right here. One thing I just want to point out is whenever you're navigating through any of the menus, what you're going to notice is vocabulary is always attached to whatever the math is that the student is inputting, which is really great for kind of having that understanding of the words that you're saying during class, as well as the symbols that they're seeing on their paper. So bridging that connection for students between the actual mathematical terms and the math symbols that you're teaching is something that NumWorks does really great. So I have 6.5 feet times, and then I'm going to do 36. Now I'm going to mix the units up and see what it kind of gives me as a result. So 36 inches, I would go back to the toolbox. It will actually bring you to the menu that we left off on. So now I can just go up to inches, click OK. It's going to add that unit in there. OK and execute, you'll see me clicking both. They actually do the same exact thing. So it depends where your hands are or your mouse is on the keyboard. That's how you're going to kind of determine which one you click on, but they do the same thing. So my answer right now is given to me in yards squared, but the question is talking about a square foot. So the student actually has the ability to copy this down and convert it to the square units that they want. So because it gives it to me in yards squared, I'm going to actually just highlight it, click OK, and it's going to copy it right down for me. And then I can tell my calculator to convert. So back in the toolbox, if I just go back 2 screens, there is a manual conversion from unit A to unit B. I can click on that. It's going to give me the arrow. And then I can go back in and I can tell it to go to feet squared. At this point, if the student recognized that feet is FT, they can use the alpha key that I showed previously to input that feet. They do need to understand that it's going from a cubic or a squared unit, so it needs to be feet squared. But then it's going to convert that into feet squared for them. So the answer for how much area we have is 19.5. But now I need to multiply that by my price of $2.25. So I'm going to say 19.5 times 2.25. So my cost is going to be $43.80. Maybe my student isn't great at rounding. The calculator will also allow that student to round this number if they're unsure what the rounding would be. In Toolbox, again, I'm going to click on it and just go back to the main menu where all our submenus are. And if we go down to decimal and we select round, it's going to have them round the digit to n digits. So they need to understand how many digits their 10th place, their 100th place, their 1000th place is. For money, we're rounding to the nearest cent. So I'm actually going to just copy this, click OK. It's going to put it in that value spot. And then I would say I'm rounding to 2 digits because it's the nearest cent. And so my cost is $43.88. So the student has the ability to look at a question from many different perspectives. One thing I'll also point out that the calculator does for anything that you input is if you're highlighting anything in the calculator and you see these 3 dots, those are going to show you additional information. So if I click on it for anything that's calculating an area, it's actually going to tell us how much elevator floors, how much of a parking space. So it's a fun little analogy for the student to kind of make a connection to a real world example. For volume, it'll talk about bathtubs or truckfuls. So it changes depending on what you're typing in. So I always encourage teachers, if you're starting to use NumWorks, look at those additional results for what you're typing in. Lastly, I'm just going to touch on quadratic formula to again show how to store values. So our quadratic formula, I have 2x squared minus 3x minus 1. This is going to result in an irrational solution. So I want to show you how NumWorks simplifies our irrational numbers as well. I'm going to store those values of a, b, and c right in my var key. So I'm going to define a new variable. You're going to have to put the number first. So 2 will be stored as, again, I'm just going to use my alpha key, is a. I will do define a new variable again. -3 is stored as b. And then lastly, define a new variable. -1 can be stored as my c. So now the student can actually just type the quadratic formula in just using a, b, and c. This is a great spot where you can use the fraction template to set it up. So I'm going to just type in the quadratic formula. So -b, I will start with plus. There is no way to do plus and minus, so they'll have to copy and change it to a minus later. Square root of b squared minus 4ac all over 2a. There we go. There we go. So there's my radical simplification. When I go back up and I copy my formula back down, I can just actually toggle over to where that plus is, hit the backspace button, put a minus, click OK, and it's actually going to give it to them both in the simplest radical form as well as the decimal form. So they have the ability to see the answer in both forms. If they needed to round this, they can again copy it down and then round that value as well. So that's a great way that they can store A, B, and C, and then just type the quadratic formula into that template right there. The next app that we're going to touch on is our equations app, and I'm going to have Rebecca kind of take over. We did use saved simulator sessions to store some of these equations, which is great for students for do nows and things like that. And that's something that you can do on the website. You can store a session so then you can pull it up for your students and already have your information stored in there.
All right. So taking you through the equations app, I can solve multi-step equations. We got quadratic that we're going to see, and then also systems. So I'm going to start with multi-step equations. The first problem is here, and we did store it, so I'm going to click that to save time. And now we're going to go into the equations app. I love this app because also this picture for it, the logo is x equals with a magnifying glass. So because remember that you're solving for x in that application. So I have my problem that I can type in and use the X key that you saw in the previous slides, and I type my equation in. When I go down to solve the equation, it will tell me that X equals -5. Okay. And then I can also see what the response would come up if I have no solution versus an infinite solution. So we'll go through this first example, 4m minus 4 equals 4m. So again, I would type my equation right in the equations app. It's stored, so it's right there. Again, to get any letter that you're solving for, you would use the alpha key and then click and find m. M is actually the number 7. And then I would go down and solve the equation. The prompt that it will tell me is that the equation will have no solution. Okay, so then they would write no solutions as their response. And then I will see this equation. I type it in right into the equations app. Okay, and again, ours is pre-saved. Again, K, you would use alpha to grab that letter, get your equation in there, and then go down to solve and see what it tells you. So now when I have infinite number of solutions, the calculator will say that vocabulary, there are an infinite number of solutions. So K can be any number, so they leave that as T, and it can work with any input. And my last, so now those were linear equations. Now I'm going to look at what happens if I have a quadratic equation and I want to solve that. So I take my quadratic equation, just like as it is, I don't need to solve and make it equal to 0, anything like that. And I put my equation in the equation app and I solve. So now you can see that if you have more than one solution, you would have, it will show me n1. I have two values for n, n equals -5 and n equals -2. It even gives me the discriminant, b squared minus 4ac is 9. If they can use that for something else that they're doing with the problem, that would be great. And then the last one is, what if I have to solve a system and I have two equations to type into the equations app?
So we're going to actually input these ones for you guys so you can see the change in vocabulary. So this is our system of equations.
So I will take my system, and go to the equations app, and I'll just type them in one at a time. So it will say add an equation. I would click OK. There are a few templates that you could choose from, but I'm just going to choose empty for right now. And I would type X. The equal sign is shift pi. 2y is alpha 3 plus 10. And then again, you could hit execute or OK, and that will bring it down. I want to add another equation. Empty. I will do 5x plus 12y. That's alpha 3. And then equal sign is again shift pi 61. Okay, so now if you are looking at my screen, it did change from solve the equation. It just changed from that to solve the system. And when I click OK, I do get both the X and the Y value for the system that it solves for.
And again, just like that focus on vocabulary for any Algebra 1 students, understanding what they're doing when they're solving a system of an equation versus just solving a linear system or solving a quadratic system, having one versus two variables. They're getting that notation with vocabulary versus solving an equation, or are you solving a system? So that focus on that vocab connected to the topic that they are exploring, which is really great. We're going to jump to Grapher now. This is one of my favorite apps in the calculator. We're going to actually look, it's a great transition. We're going to look at our system of equations from the Grapher standpoint. So how would it show a system of equations in Grapher? I actually have a quadratic linear system. So I have f of x and g of x. We are going to input them as f of x and g of x. So the one thing with Grapher is you actually do not need to solve for y equals. For this one, they are solved in terms of f and g of x, but that's just something I always like to note. If we go into Grapher, I'm going to store f of x first. Just like equations, you're going to add an element. So I'm going to click OK. I'm going to go to my templates. Your templates have a bunch of options in there for students. For this one, we're going to actually choose our f of x. And then I can just edit this from there. So I can say -3 and then x and click OK. Same thing with what we did for equations. We're going to add an element. This does notate that this is a linear function. I'm going to add an element. I will use templates. You can also use g of x on the alpha keyboard. It works either way. What you will notice is it defaulted to g of x, so it will not allow you to put two functions that are named the same thing with different expressions, which is really nice. So this changes to g of x, and I'm going to type this in as x squared plus 2. Okay. Now I know that my f of x is going to be red and my g of x is going to be blue. I always make the reference as these tabs up here are kind of like our computer tabs. So you're actually just going to go to the tab where you want to explore. So I'm going to go over to graph. There's also a plot graph button. Either way will get you to the same point. So if I go over to the graph tab, you're going to see that I have my quadratic in blue and my line in red. I want to focus on these two black dots that are being shown on my function. If I want to zoom in, all that the student has to do is hit the plus button. So let's say I want to zoom in, I hit the plus, I'm zoomed in, I can zoom out, and I can still see those intersection points. If I click auto, the calculator is going to go back to the window that it originally chose for the function. So I'm actually going to scroll down. The calculator will automatically snap to those intersection points. It will also snap to other key points. So let's say I wanted to just focus on the intersection points. The student actually has the ability to just click OK and then hit find. So this is a submenu where I can actually just focus on the points of intersection. So I can click this, and now it's only going to toggle when I trace between those two intersection points. So you can talk about the system and the solution in that way as well. I always like as well that this notation is used on a lot of questions, whereas f of x equal to g of x, it's actually giving them that notation here. F of x is equal to g of x, which is equal to the value at that point, which is really great. Next, we're going to jump to piecewise functions. This is something that is actually a template that's really great to use because the student is going to be able to type in a piecewise function exactly how they would see it on paper. I'm just going to go back to expressions. To clear these out, all that you have to do is hit the backspace button. So I'm going to hit backspace on both of them, and it clears it all the way out of the calculator. Now I'm going to just add an element. So I would click OK. And for a piecewise function, I do want to use a template. So you don't want to just put two functions in and restrict the domain. There is a piecewise template that will look exactly like our g of x shown in the question. I'm going to scroll down. Right now, it's defaulting to f of x, but let's say I want to be exactly like the question shown. I can actually change this to g of x so that they're using the same notation. And then I'm just going to go in and edit. What I also like about the keyboard is they are going to be able to edit characters like they would on a computer. So if I hit backspace, it's just backspacing whatever character's in front, and then it lets me type from there. So I have 5x, and then this is just a less than, and I need it to be less than or greater than. So I can actually type in a less than or greater than sign in two spots. I can do shift less than, shift equal to, and it will actually make that symbol. Or you can also access it in the toolbox because it's not being shown on the main screen. So that is also where you can find it in those two places. For my quadratic, I'm going to type in x squared plus 4 and then this needs to be greater than, and these need to be values of 3. And the question is asking me, what should the point look like at x equals 3? So there's going to be 2 points, and we want them to differentiate when it will be open and when it will be closed. So they're going to be able to make that connection between these symbols and what the open and closed circles actually look like. So I'm going to click OK. I'm going to go over to graph again. And then when I look at my x equals 3, again, if you would like, you can have the student zoom in and move over and trace at those points. So now I can see that at 3, I have an open circle and a closed circle. So my closed circle is a part of my line and my open circle is a part of my quadratic. They can also type in the value 3 and click OK, and it will bring them right to that value. So if I was maybe over here and I need to know what it's doing at x equals 3, I could just type 3, and it's going to pull me over to that point so they can explore the difference between the discontinuities at those points. I'm going to shift my calculator to the other side so that we can look at some inequalities. So your system of inequalities, you're going to type this in similarly to your piecewise with your inequality symbols. So I'm going to go back and over to expressions. Again, to backspace this out, I'm going to highlight it and just hit the backspace button. And graphing your system of inequalities, I really love because you're going to be able to see your dotted, your solid, and your shaded areas. So you can decide to use a template if you would like. So you can go to templates and we can click on our inequalities template. Because this is y is greater than or equal to, I'm actually just going to type it in. So I'm going to say y is greater than or equal to -1/2 to get over. I'm just going to hit the over key to move your character. X minus 3. Okay. It will read as an inequality. I can add another element for a system. And then I'll start with alpha 3 for y minus 2. The X key is less than 5 and click OK. Now again, you can go to plot graph or up here to the graph tab. And this window is set where my window was for my piecewise function. So let's say you have a student that is getting this window and they don't know how to get it back to see the complete function. We have an auto button. This auto button is going to fit it so that the student can see everything necessary that they would need for understanding that problem. So it will always show interceptions, intersections, roots of the lines, things like that. In this, you'll see that this is our solid line, and we also are shown our dotted line, and our intersection has an open circle at it to show that this is not a solution, but it is a key point as an intersection, but it's not a solution to our system. I also really like if I'm actually going to open this up so you can see the shading a little better. If we look really closely, I always loved that we have red dots, we have blue dots, and then in here, we don't have purple dots. We have red and blue dots, showing that those red and blue dots are solutions for the red line as well as the blue line. So you're kind of getting that conceptual understanding with what a solution set really is for an inequality. For the next question, we are going to look at some transformations and how the calculator actually reads transformations in the form of a transformation, so in terms of f of x. Because it understands function notation, I can actually input these values as f of x. So I'm going to do alpha f of x equals, so shift pi, x squared minus 6x plus 9. And just so that our window is fit, I'm just going to make sure our auto is turned on, which it is. And then your next expression for g of x, I'm going to add an element again. You can actually have a student type in g of x in terms of f of x. So g of x equals f of x, so alpha f of x, and then it's plus k. So we need to test 0, 2, -3, and -2. I would always notate that f of x is going to be my red function. So we want to see how the red is going to change to what the blue is. I'm going to start, we know 0 is not going to move it at all. So I'm actually going to start with 2 and just see what happens. So now I'm going to see if my blue function is below my red based on that graph. When I graph it, I can see that that would not be the correct answer because that actually moved it up 2, not down 2. So now the student can actually go back and just edit it. Let me see if I do -2, which would be option 4, if that would change it. So now the student can see that this was your f of x function, notated it from f of x, and then your g of x is below it at 2, which they can match with the graph shown. So you can actually have students explore transformation rules inside of functions that are preset, which is really great for exploration and kind of understanding of what those rules really do visually for the graphs. The next app we're going to touch on is our regression app. Similarly to equations, I actually pre-saved some sessions, especially for the first one that's a little longer, just for the sake of time and making sure we could get through all of the apps that I really want to show you for Algebra 1 today. So your linear regressions, I would use my regression app for things other than just linear regressions. Here we go. Okay, so for this one, I'm actually not just running a linear regression, but I'm comparing different types of functions. So I have f of x, g of x, h of x, and j of x. But I don't know what these look like. I don't know what the equations are. So as a student I met with, I need to understand the pattern of my numbers. So what I did was I actually preloaded these into our regression app. If you're following along on the emulator, feel free to open the regression app and kind of start typing those values in. As the regression app, when I click on this, we are going to input the data just like they see it in the lists. Right now, I currently have these turned off so that if we wanted to, we can turn one in at a time. But I typed in all 3 tables that were shown in my question. So for table 1, if I wanted to turn it on, I can just go to X1. It will be on by default. And I can actually click show in graph and stat. So that's going to allow me to graph it. So to start off, if your student went through and typed all of these in at the same time, they're going to see that each table that they typed in will show up as a different color. When you're typing these in, they will automatically all be on. So I'm just turning them back on because I turned it off previously. So I have red is my f of x, g of x is blue, h of x is green, and my j of x was yellow. So I'm going to go to graph, and that is going to make a scatter plot with all of these points listed on it. And that might help a student kind of understand, I'm looking for linear, I need to find points that kind of look like a line. So find the color that looks like a line. So I'm going to go to graph, and that might be a little too crazy for a student to see. So that's where I like to show turning on and off the plots. So if I was a student, I would say, okay, maybe the green is looking like it's curved down. So I am going to eliminate the green answer. So I'm going to actually go back in and turn off my green plot. So I'm going to go through. So choice 3, h of x is not going to be our answer. I'm going to turn that one off. So now when I go, again, process of elimination, I say, okay, now I can see a little clearer, and the blue kind of looks like a line, but this one's a little weird. And my red, that one's curving, so that's not going to be a line. So I'm going to actually go back in, and I'm going to turn off my red. So I'm going to go in. They can also just delete their red. I just like to show that you can turn things on or off as well. So I'm going to eliminate choice 1, f of x is not my answer. So now I'm between this yellow that looks like it's making a perfect line and this blue that looks a little funky. So for my blue, I'm actually going to just delete my blue just to show you that you can also just delete your lists as well. So I can just highlight it, hit OK, and I can just say clear this. I don't want it. Clear that out. Clear my Y's. I don't want it. And now it's gone. So we don't have that blue option anymore. Now, let's say the student wants to just triple check that that's linear. To run the regression, as long as it's selected on one of those points, they can just click OK or tab up here and hit regression. Choose the model. So I would choose linear. I can see that, okay, that's fitting it really great. and my R value is 1, I know that this is my linear regression equation. So again, having the students start with maybe not knowing anything about those functions and then being able to problem solve, looking at the graph, connecting it to the equation, and actually using that regression app for understanding different functions. The next question is going to be actually running a statistical regression. I didn't type this one in, so I'm actually going to jump back to my side emulator here, and I'm going to type that data in. So I would go to regression app. One thing I love about regression is if you are going up by a constant rate of change. So for this one, I'm going 0, 3, 6, 9, 12. It's going up by 3. You can actually just type in 2 values and the calculator will detect that it's going up by a constant rate of change. So when I type in my 1100, it's going to say 6 for my X value. So it's kind of a little time saver in there. And then 920 was my last value. To run the regression again, they're just going to go to graph. I would click OK. They're going to see those points. You can kind of have them make the understanding that, oh, yep, my R looks like it's negative. Those points are going down. It's going to be a negative slope. I can click OK again, pick my model. This is where I would run my linear regression. It's going to give you the line of best fit. And then click OK again, and you're going to be left with the regression equation, as well as your R value, your R squared value. And then right from this screen, the student can actually predict Y given X or find X given Y. So they can go either way if you're doing a question where they now have to use that regression model to predict a future point or a future statistical data that they want to understand. What's also really nice is I can actually store this value as, let's say I'm going to store it as R. So all that I did to store this value is I highlighted it. They could also copy it. So let's say your student struggles with rounding. They can actually copy this correlation coefficient. So I can store it. I can hit var and maybe store it as R. And then I could always jump back to my calculation screen and use that rounding feature that I showed at the beginning so that the student is correctly rounding to the nearest 100th place as well. So again, our apps will talk to each other and anything that you stored in the calculator will be stored between all of the apps so you can use that variable or that function as well. All right, I'm going to minimize this over. And the next app we are going to be looking at is going to be our statistics app. This is going to be our last app that we're going to look at. And then I'm going to kind of give you some more information just about the calculator, some resources that we have as well. There we go.
Okay. So our statistics app, for this question, I am going to type in the data to show you how to use it. So in the statistics app, let me pull up the side. Okay, so we're going to go home and go right over to statistics. So I have 2 different sets of data. We have Andrea's test scores and we have Joe's test scores. So I'm going to use my first V1. I'm going to use that as Andrea's test scores. So we have 82, 87. Oh, and also on the right-hand side here, that's the frequency. So they're only coming up 1 time. So that's going to auto select 1 because we only have 1 of those numbers. We have 82, 87, 90, and 84. Okay, so Andrea's test scores have been added, and now I can just go over with the right arrow and move over to V2. So this is going to be all of Joe's test scores. Again, they're only showing up as a frequency of 1, so that's going to auto-populate as a 1. But if you had more than 1, you could always change that and put in a different value. We have 91, 78, 94, and 67. Okay. So this question is about comparing data. There is, for each of the answer choices, they're asking about comparing the test scores, their mean and their standard deviation. So now that I've entered both columns of data, it's really nice when I go up to stats, I can see them side by side. So we're going to go up. So we have data. We can see it as a graph. I have stats though, which I'm going to look at. So I would go through this question. It says which statement is correct. So if I read each of these question answers, it says both the mean and standard deviation of Andrea's test scores are higher than Joe's. So I just have to remember Andrea was the red and Joe was the blue column. And I can go through and scroll down and see the word for mean, but also what symbol it goes with. So when I go down this column, I can find mean. And again, there's population mean. There's also the sample mean. We're going to use population. And the symbols are there. So I would compare the two and they're side by side. Again, the student just have to remember Andrew is on the left side. I entered that data first, and then Joe was on the right. And the other one was standard deviation, which is right underneath it. And then again, the words are there for the vocabulary, but also along with the symbol. And I would compare and go through. If one is incorrect, I would do process of elimination that way to get rid of answer choices and to compare between the two populations, Andrea and Joe, their test scores. Okay, so that's mean versus standard deviation. And then the other statistics question that I'm going to show is a box plot question. Okay, so we have a data set and I need to construct a box plot. Well, in the calculator, if I have this data, and I did pre-store this data, you would type it into the statistics app the way that I just did. So I'm just going to show that. In statistics, again, I just have all of the values with a frequency of 1. I type them all in as a column and it will auto-populate that the frequency is 1. So we don't really want the stats for this question. It wants us to construct the box plot. So if I go into graph, there's a couple of different choices that I can choose from. There's histogram, we have frequency and probability plots. I want a box plot. So if I click that, I can see the visual of what I need to make. But more importantly, the 5-number summary is there. Along the bottom, it tells you what it means. So this first line is my minimum value of 4. So I would draw that on my box plot. The next, it will say first quartile is 18. Instead of saying second, it will say the median. Median, aka the second quartile, would be 28. Third is 46, and then my maximum value is 56. So it does give the 5-number summary with the words for what they mean, along with the numbers. And I would just draw this for my answer on the number line. Yeah.
So lastly, I just wanted to touch on a few things. So sometimes when we're going through these apps and we're thinking about teaching our Algebra 1 students and kind of the different levels, the question is, what if I don't want the calculator to do that, right? What if I'm teaching multi-step equations or I'm teaching factoring and solving by factoring with my quadratics and I don't want the student to have access to actually using that? The NumWorks calculator actually has a customized test mode that teachers can customize what's on and what's off. So if I'm doing my unit on simplifying radicals, let's say, and I don't want it to simplify square root of 50. I want it to just give me the decimal approximation, and I want my student to be able to break that down into square root of 25 and square root of 2. The calculator, you can go down to settings, and it kind of gives you the autonomy to choose what you want the calculator to show. So if you go down to test mode, this is where you can play around with press to test. Press to test is actually going to allow us to turn things on and turn things off, and it will lock any handheld calculator into that mode until the teacher plugs it back into a device and unlocks it. So it's secure for testing and in your classrooms if you want certain features off. I'm going to just turn off some features so that you can kind of see what the calculator would do. So exact results, I can turn that off. That's going to not simplify my radicals. And I'll turn off equation solver. And let's say you're doing your inequalities unit and you really want them to understand the test point and solving correctly and subbing that in to figure out their shading. You can also turn off inequality graphing. Implicit plots will make them solve for y. So there's a bunch of different things that can be turned on or off. You would then just activate test mode. When it's activated, you're going to confirm. And then you can have this graduation cap right up in the corner. This is how you're going to know that your calculator is in a test mode. So even if a student accidentally puts it in a test mode, you will be notified by this graduation cap. That means that something is off on the calculator, either you preset, and then it would just have to be plugged into a computer to reset. So now if I take a look at going to equations, so I'm giving my multi-step equations quiz and I don't want them to use that app. If they try to go into it, it's going to tell them that that application is forbidden in the test mode that it's in. If I jump back to calculation and I try again, let's just do the square root of 50. It's no longer going to simplify that into simplest radical form. Same thing with like your trig functions. If I did sine of 2 pi over 3, normally that would actually simplify into simplest form, and it will only give the approximation on there as well. Graphing an inequality, it would actually no longer graph that inequality for you. So it will turn off things. So you kind of have the autonomy as a teacher for when things are on, maybe if you're doing exploration or activities, and when things are off when you're in a testing situation and you really want that Algebra 1 student to show what they know algebraically about that topic. So that's something I really like, is that you have the autonomy as a teacher in your Algebra 1 courses to kind of problem solve. What are the barriers that my students are having? How can I use the calculator to kind of break those barriers for that student? And then when is it time to kind of test them on what they actually know and maybe put some of those barriers back up for that student to just show what they know algebraically. So that is pretty much everything that we're going to go through today. We do have a bunch of resources. Again, this video is going to be posted on our website under webinars. And we do have a bunch of resources also on the website that have some more support materials as well. If you need a certificate of completion, you're going to get an email from me if you signed up for the webinar that will just have a form that I will ask if that's something that you need, and then we can get that together for you and get that sent out as well. But I thank you all for coming today. We enjoyed kind of going through some of the main features of the calculator with NumWorks. If you are a math teacher and you don't yet have a free sample calculator, feel free to reach out to us. We do provide free sample calculators for any math teacher. So that's a great way to kind of get your hands on the handheld and try some of this stuff out with your students. But thank you. Thank you all for coming and have a great Thanksgiving.